Hello there. In this lecture, we're starting a very big and complex topic, which is exponents. Basically, exponents are repeated multiplication. You remember how multiplication is repeated addition, and just like that, exponents are repeated multiplication. Let me show you what I mean. In this example, I have 3 to the power of 4. If you were to write it as multiplication, it will be 3 times 3 times 3 times 3. So 3 times itself 4 times. This number 3 that gets multiplied by itself is called the base. And the number that indicates how many times do you repeat the number, and the number that tells you how many times you're going to multiply 3 by itself is called the power. Often students make very fatal mistake. They think that 3 to the 4th power is the same as 3 multiplied by 4, and that is wrong. So please do not make that mistake. 3 to the 4th power is not the same as 3 multiplied by 4. Let's verify that. Does 81 equal to 12? No, those are two completely different numbers. So therefore, 3 to the 4th power is not the same as 3 times 4. Now let's write some rules of exponents. I want you to write this down. I want you to memorize it. If you cannot memorize it, you can always substitute these numbers and check yourself. Very often, students, myself included, come up with their own exponent properties. And those usually turn out to be wrong. So you gotta memorize it or verify yourself all the time. First rule is if you see a number or a variable with no power, the power is actually 1. For example, number 5 with no power means 5 to the 1st power. Next rule, or I would say property, is that any number to the 0 power is going to be 1. For example, you have 100 to the 0 power. 100 to the 0 power is going to be equal to 1. 100 to the 0 power is not going to be 0. Please memorize it. This is also another mistake I see people do very often. Even like a billion to the 0 power is also going to be 1. Any variable to the 0 power is going to be 1, whether it's positive or negative, no matter how large or how small that is. Next rule, we have a to the b power plus or minus a to the c power. So here's the thing, there is no rule for this kind of exponents. I often mess it up, I see others mess it up. Look, this is the topic when people start getting confused. So I'm going to point out the mistakes that people often do, so you keep that in mind and don't do them yourself. So even if the base is the same, you cannot add or subtract your exponents. It's just not going to work. If you forget this rule, try to plug in some numbers. I don't know, like 3 to the 2nd power minus 3 to the 1st power. And you will see that they are not the same. Next rule is if you have the same base, like a to the b power multiplied by a to the c power, you're going to add your powers. For example, you have 5 to the 8th power times 5 to the 3rd power. That is going to be equal to 5 to 11th power because I added my powers. Look, if the bases are not the same but exponents are, this is not going to work. For example, you have 5 to the 8th power multiplied by 3 to the 8th power. In this case, you cannot add exponents, you cannot add the bases, so there is no rule for this. No rule. No rule. Just like here, there is no rule, okay? Only the base can be the same, and it needs to be either multiplication or division. Next example or next rule, I will show you how to do it with division. When you divide exponents with the same base, you are going to subtract numerator with the denominator. So a to the b divided by a to the c equals to a to the power of b minus c. Let me show you an example. Here I had 10 to the 4th power divided by 10. To which power is this 10? I just showed you. If there is no power shown, the power is 1. So I'm going to subtract 4 minus 1. And my final answer is 10 to the 3rd power, or 10 cubed. The next rule or property is the following. You have a to the negative b power. That whenever you see a number or exponent or a variable, anytime that you see an exponent with a negative power, you are going to use the reciprocal. So if you see to the negative power, it goes to the denominator. If it is in the denominator with a negative power, then it's going to be put in the numerator and remove that negative. For example, I have 2 to the negative 7th power. That will be equal to 1 over 2 to the positive 7th power. Does it make sense? You can use them interchangeably. This is why when you divide, you subtract, because actually on the bottom, your power is negative. And when you add a negative number, you're actually subtracting. Let's start doing some examples and apply these rules. In this example, we have x to the 4th power. In this example, we have x to the 4th power multiplied by x to the 6th power. When we multiply exponents with the same base, what is going to happen? Look at the rules. Powers are going to be added because base is the same. And when I add my powers, I am left with x to the 10th power. Let's just do a few more. In this example, I have a to the 9th power multiplied by a to the 12th power. What am I going to do? I'm going to add my powers. So 9 plus 12. And your final answer is a to the 21st power. In this example, I have 3 to the power of 17 times 3 to the power of 5. What is going to happen? We are going to add our powers. So 17 plus 5. So the final answer is 3 to the power of 22. So far, so good. Alright, let's do some examples with division. Again, all you have to do is apply these rules. If I haven't written a rule for you, it probably doesn't exist. I will keep exploring. I'll show you more rules in the next video because I do not want to overwhelm you. We just start doing everything by little steps. Okay? In this example, I have 4 to the power of 19 divided by 4 to the power of 9. What is the rule when we see division? We are going to subtract our power. So 19 minus 9. Let's do it. And your final answer is 4 to the power of 10. In next example, I have a to the 25th power divided by a over 7. No. In next example, I have a to the 26th power over a to the 7th power. What is going to happen with the power? We're going to subtract them. So 26 minus 7. And your final answer is a to the 19th power. Here we have x to the 18th power divided by x to the 25th power. What is going to happen with our powers? We are going to subtract them. And we're left with x to the negative 7th power. Now, let's use our properties, or I guess rules, to rewrite this. And we can rewrite that as 1 over x to the 7th power. By the rules of math, like by the standards, you're not supposed to leave negative exponent. So just keep that in mind. Try to always write that as a fraction. Let's practice writing negative powers in the form of a fraction. Here I have y to the negative 8th power. What is going to happen? Y and 8 go into the denominator and the negative goes away. So you're left with 1 over y to the 8th power. Here I have 5 to the negative 2 power. What is going to happen? I'm going to put 5 to the 2nd power in my denominator and remove the negative. Alright, I hope it's starting to make some sense. Now let's combine everything that we've learned into some challenging problems. Here I have a to the 6th power multiplied by a to the 12th power all over a to the 18th power. What are we going to do? I like to deal with my numerator first. If you like to deal with the denominator first, your choice. The answer is not going to differ. I have a to the 6th power multiplied by a to the 12th power. What is going to happen with the powers? I'm going to add them. And when I add them, what power am I getting? 6 plus 12 is 18. But look what is happening now. I have a to the 18th power on top and I have a to the 18th power on the bottom. What are we going to do? We're going to subtract. So a to the power of 18 minus 18. 18 minus 18 is 0. So a is to the 0 power. What does that mean? Look at the properties. Any number to the 0 power is going to be 1. Look at that. We applied a few rules, a few properties once. Let's do another example. Here I have a to the 16th power multiplied by a to the negative 7 all over a to the 8th power. What are you going to do? Listen, there are several ways. I'm going to show you what what I do, but you can use your own way, how you prefer it. Sometimes it's easier to bring this down first. Sometimes you don't have to do that. I'm going to deal with numerator first and then deal with the denominator. That's how I like it. If you like it, do it. If you do not, if you prefer to moving it to the bottom, do it first. Whatever works for you, as long as you're getting the right answer. What is going to happen with my numerator? I'm going to add power. So 16 plus -7. And what is 16 minus 7? That is 9. Now let's subtract, right? Because we have division, and this means to the negative power minus 8 is going to be power of 1. And any number to the power of 1 is the number itself. So a to the first power is just a. And let's do our final challenging problem. Here I have a to the 21st power multiplied by a to the -8 power divided by a to the 11th power. What am I going to do? I like to deal with my multiplication first. Actually, we can do everything together. Let's do it. What is going to happen between 21 and -8? We're going to subtract them, right? Because here you have -8. And what is going to happen with my 11? Since I'm dividing by 11, it means I'm going to subtract 11. So you have 21 minus 8 and minus 11. Let's do it. 21 minus 8 and minus 11 is going to be just a to the 2nd power. Alright, I hope that it makes sense. Write this down. If you see addition or subtraction, or if you multiply with different base but the same power, there is no rule for that. Please don't come up with your own rules for exponents. Don't do that. So like, subscribe, leave a comment, and I'll see you in the next lecture about exponents. So keep an eye out for that.